Welcome Algebra to Lesson 6.3 on Similarity. It covers pages 160 to 164 in your textbook. We'll begin with vocabulary. In the last lesson, we talked more about congruence, where things are exactly the same. Similarity moves on from that concept where similar figures will have the same shape. However, they will be different sizes. So how do we determine if a figure is similar? Well, in the case of triangles, two triangles would be similar if the ratios of their corresponding sides are equal. So we gotta kind of keep how to do ratios in mind. And if all of their corresponding angles are equal. So both of these have to be in play in order for two triangles to be similar. Therefore, triangle ABC is similar to triangle XYZ if AB, so this would be side AB over side XY is equal to BC over YZ, which is equal to CA over ZX. So if all of those are equal in ratio, and if angle A is equal to angle X, and angle B is equal to angle Y, and angle C is equal to angle Z, then we will have two similar triangles. Going on from just triangles, we can also apply these same rules to polygons, so objects of more than three sides. So again, similar polygons are in play if the ratio of their corresponding sides are equal and all corresponding angles are equal. So again, both of these have to be true in order for two polygons to be similar. Therefore, quadrilaterals, for example, quadrilaterals ABCD and PQRS are similar if AB over PQ is equal to BC over QR and also equal to CD over RS, and finally DA over SP. So if those ratios are all equal, then we can go on and check out the angles. So if angle A is equal to angle P, angle B equal to angle Q, angle C equal to angle R, and angle D equal to angle S, if that all happens, then we would have two similar polygons. So let's put all of this stuff into practice, and we're going to start with try at 8 on the bottom of 163. So try at 8. It says in the diagram, and if you look at those two triangles, in the diagram, triangle ABC is similar to triangle XYZ. So they're telling you right off the bat, those two triangles are similar. And then it says AB, that means side AB, is 6 inches. Then the corresponding side, XY, is 10 inches. YZ is 9 inches. The measurement of angle XYZ is 113 degrees. So you got some information. Now, having that and knowing they're similar triangles, we are to find, first of all, in A, the measurement of angle ABC, and then in B, the length of BC. So if the two triangles, it already tells us they're similar. So that's a given. So we don't have to go measure anything. Therefore, since angle Y corresponds to angle B, now notice you can call them by single letters by taking the midpoint in each one. So angle XYZ measuring 113 degrees would be the same corresponding angle as angle ABC. Therefore, they are both 113 degrees. And you can do that because of the properties of similar triangles. Going on, finding the length of BC. Well, BC corresponds to YZ, and that is equal to AB over XY. Now we do AB over XY because those are two corresponding sides and both of the dimensions are given, 6 and 10. Here, BC corresponds to YZ, but we're only given the measurement of YZ, which is 9. So we have X, which is what we got to find, over 9 is equal to 6 over 10. Now notice we have equivalent fractions, so we do the crosses. 10x equals 9 times 6 is 54. You divide through by 10. X is 5.4 inches. And that's how you do it. So you put a lot of things that you already know into use. So basically we have equivalent fractions when we do ratios like that. And if they are equivalent, they are similar. Now moving on to the next page, 164, we're going to be doing try it number 9. And here we have a polygon. It says in the diagram, quadrilaterals ABCD and PQRS are similar with, so again, similar shapes. Now notice one is flipped. You know, they're not drawn side by side so nicely as the triangles were. So you got to kind of flip and turn a little bit to get them situated, orientated. Actually, you just got to rotate it to the right one. Yeah, you just got to rotate it, turn it to the right one click. Anyway, they're similar. And we have BC is equal to 25 centimeters. Now they say DA, but really they should have said AD. That's kind of a weird thing. So I'm going to say AD is equal to 16 centimeters. The measurement of angle BAD, or angle A, is 81 degrees, and the measurement of angle ABC, or rather angle B, is 83 degrees. PQ, side PQ, when you find it, is 25 centimeters, and SP is 20 centimeters. So you got all that information. Now with all that information, we can find the measurement of angle PQR, or rather angle Q, to begin with, an A, and then B, the length of AB, and then C, the length of QR. So first of all, let's try, start with the angle measurements. So quads ABCD and PQRS are similar, given that angle PQR is 83 degrees. Therefore, angle ABC is also 83 degrees. Did I say 83 degrees the first time? Hope so. They're both 83 degrees. So just take a look at that picture and see how you had to turn it around. But if you can't turn the sketch around, just look at the order of the letters. P, Q, R. So the first 3 letters here, Q in the middle, A, B, C, B is in the middle. So these two are going to be, they're going to be angles that are the exact same thing, so 83 degrees. Likewise, we can set up our ratios. So B wants us to find the length of AB. So AB corresponds to PQ, and we want to find, actually they take the two that are given. They take AD and PS, or DA and SP, whichever way you want to look at it. But anyway, those two correspond, and we take those because those have, they're given to us in the diagram. So we want to find this. That's the X over 25 is equivalent to 16 over 20. You could pick, no, you really couldn't, because that's all that you are given. 16 over 20. Given another side, but that does not work. Okay. Anyway, you have to take a side where you're given two things, the 16 and the 20. Okay. Moving on, equivalent triangles. So 20x is equal to 400. Divide through by 20, x is going to be 20 centimeters. Now again, they want us to find QR. QR corresponds to BC, so that's the first ratio. And we pick two other ones that are similar. So we take one from the same quad, PS, which is similar to AD in the second quad, or the first quad, whichever way you want to think about it. So we're given 20 over 16. So it's the same thing here, we just flip them. 20 over 16, x over 25. 16x equals 500. Divide through by 16, x is going to be 31.25 centimeters. This will become very evident and easy once you start working with it. However, if you have any questions, please ask. I will give you your assignment in class, as I did not bring that home with me for this video. So yeah, you'll have it already before you watch this. Okay, thank you. Do good math, and please ask questions if you get hung up along the way.